Hey everybody, this is expert tutor Brian coming at you from ScoreBeyond headquarters in crisp fall Menlo Park, California. Let's tackle this SAT question of the day, which you can see is a math question. Now, you might look at this math question, especially expression at the top here, and think, oh, okay, I just add up the different x's and reduce this expression. However, you have to follow something you learned probably a long time ago in math class, and that is PEMDAS. Now, PEMDAS is an acronym that allows us to remember our order of operations. The P stands for parentheses, meaning you do everything in parentheses first before you move on to other operations. E stands for exponents, so you take care of those next. M stands for multiplication, D for division, and since these are basically cousins, you can do those in either order. The A stands for addition, S for subtraction, and again, you can do those in either order as well. They're also kind of like cousins. So let's take a look at the expression that this problem gives us. We see two sets of parentheses here around our polynomial and binomial. So we have to work on the stuff inside those parentheses first, or at least pay attention to the parentheses. For the second expression here, or binomial, you also see this squared sign, right? Since that is our second operation, parentheses, exponents, multiplication, division, all that stuff, we basically have to do the exponent operation on this binomial before we can worry about reducing the whole thing with multiplication, division, addition, subtraction. So let's do that. X minus 4 squared is basically the same as x minus 4 times x minus 4. So now we have two binomials multiplied together, and that's going to require us to use FOIL, right? Which means first, outer, inner, last. If we multiply the first terms together, we should get x squared. If we multiply the outer terms together, we should get negative 4x. Don't forget your minus sign in front of the 4. If we multiply the inner terms together, we would get another negative 4x, and then the outer terms together, we would get a positive 16, because again, both of these are negatives. So now we have a sort of polynomial here. We can simplify it by combining like terms. In this case, we have two terms with an x in them, so if we combine those together, we should get x squared minus 8x plus 16. Great, so we've taken our binomial squared and created this quadratic polynomial right here. We can now combine it with the other polynomial. Before we do though, don't forget about this negative in the original expression. Since it was before the parentheses of our binomial, we have to apply it as if there are parentheses around our now quadratic polynomial, now that we've turned that binomial squared into this new expression. So before combining with the first polynomial, let's just rewrite this new polynomial we created by distributing the negative all the way through. So negative distributed to this x squared term is going to give us negative x squared. Negative distributed to the negative 8x term is going to give us a positive 8x. And the negative distributed all the way to the 16 term is going to give us a negative 16. Okay, so now that we've simplified our second expression in this larger expression the question gave us, let's just rewrite the initial expression in the front. So we have x cubed minus 2x squared minus 10x. So now that we have all our terms lined up and the negatives distributed, the binomial has been foiled, we can move into the sort of multiplication, division, addition, subtraction operations. Since we don't need to solve for anything here, this question isn't necessarily asking us to solve. Just look for an expression that is equal to the one above. Let's just start simplifying. There are no other x cubed terms in this expression, so let's just leave x cubed by itself. However, we have a negative 2x squared and a negative x squared. Combine those together, you should get a negative 3x squared. We also have a negative 10x and a positive 8x. Combined together, you should get a negative 2x. And we don't really have any other non-variable numerical terms, so let's just leave our negative 16 by itself. So we've combined all like terms, we've reduced the expression as much as we can without knowing what x actually equals. We can't do much more work on this, which is great because this final expression here happens to be the exact one we see in answer A, so we know that we've reduced it plenty and we can just bubble an A. So kind of a medium, maybe medium hard problem if you have trouble with PEMDAS or remembering the little steps in a problem like distributing a negative. However, if you lay out all those steps, take it one thing at a time, it shouldn't be too bad. Take your time on a question like this because you'll get rewarded with a fairly simple point. If you need help on questions like this one, or you just want to work on algebraic expressions, how to reduce them, the different tricks you can use to simplify these problems on the SAT, tap the tutoring button at the bottom of the screen, or if you're on our blog, click on the tutoring banner at the bottom of the page. Our tutors can help you tackle questions just like this and learn those skills to improve your score on the SAT. Okay, see you next time.